We all know soil testing is important, but have you ever wanted to know what goes on inside the lab? Well, I'm at Rutgers to find out. Come with me. Soil testing is economically prudent. With the right application of nutrients, you can save lots of money. To find that out, get a representative sample of your field.
Garbage in, garbage out. If you don't give us a good sample,
You won't get good results. This is where 2 cups or up to a half gallon of your sample is sent and labeled for analysis. Containerized into these chipboard boxes, samples are stored to dry. You might notice bits of rocks and grass in these samples. That is why the next important step is to sieve them.
the sample is exposed to this beating action. And then when we decide, it's been beaten up enough, we release it onto the sieve.
The rest gets stored. Then, onto the main attraction, the Malic 3 extraction. This is a cocktail of nitric acid, salts, and chelating agents to displace all the nutrients from the soil. This makes the nutrients soluble so they can get filtered into tubes. Organic matter and soil particles get trapped in the filters and the remaining liquid goes into the instruments for analysis. Now for finding specific nitrogen levels, we use this bad boy, the auto analyzer, also known as a segmented flow analyzer. While the Malic 3 test looks for minerals like potassium, phosphorus, this analyzes plant-available nitrogen. It looks for peaks in the data to tell us exactly how much nitrogen and ammonium is available for your plants to use. It turns out soil testing involves high-tech color matching. This pumps reagents into glass coils that are mixed with the sample. The sample is injected into different packets that are separated by bubbles. By the end, the liquid changes color and the wavelength is measured. Then, using argon with an optical emission spectroscopy machine, you can excite particles to measure and visually see the wavelength intensity of each element. This lets you quantify the amount of that element. This fantastic bot tests the pH of our soil, going one by one to each sample, wetting it, stirring it, and then rinsing itself like a fine little gentleman. Once our fine gentleman knows the pH of each sample, any one that is less than 7, it goes back and dispenses a buffering agent. We can't forget to measure the electrical conductivity, or the EC. Next, using hydrometers, they follow Stokes' law to measure the layering of sand, silt, and clay. Samples are then weighed and tossed into the 900 degrees Celsius furnace.
And the gases are being collected and going through a detector. It's a thermal conductivity detector.
Nitrogen passes through the system while carbon stays behind in these cooled tubes. A computer measures the nitrogen passing, then reheats the carbon to measure it. Finally, with the Solvita microbial respiration test, we're aiming for a yellower score, which means high microbial activity. Like and follow for more information about soil.